Okay, so let's move on to CTL questions. Question 1. For the CTL formulas, what are the atomic propositions for the models below? So all models have the same atomic propositions. So we can see here, we have a state. Now I've put the atomic proposition into the name, and zoom in, into the name of the states. So you can see this is bad, 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 good, bad, bad. So you can see that our atomic propositions for this model is bad and good. So there are our two atomic propositions. Which makes our power set, if you remember from the first lecture, empty set, bad, good, or good and bad. So we have 4 different labels we can apply. What are the CTL formulas that satisfy the properties in the models? Can an LTL formula also satisfy these properties? Okay, so let's do part 2. I'm going to let you do part 3. So go back to lab 1, look at LTL formula and see if you can get these paths. But I'm going to do question 2 for you. What are the CTL formulas that satisfy the properties in this model? The atomic propositions we are concerned with is good. So when you're writing these atomic propositions, I'm going to be using the good as opposed to the bad. Note that atomic propositions use small letter notation and temporal operators, quantifiers use capitalized letters. So as you can see here, quantifier, temporal operators is capital, and atomic propositions are traditionally small, lowercase, as these are reserved. In Cinco, all formulas must be inside brackets with a space between the CTL formula and atomic propositions. Also, if there is more than one atomic proposition, then they are separated by a space. So this is just for our Cinco model checker. This is just our way of doing things. There are models available to download to represent these graphs in Cinco, so you should all be set up with these already. So let's do example 1. So this is the desired outcome. So we want a path. So we can say green is positive, red are counterexamples. So what do we want? We want a path that goes to good. Remember, we're concerned with good. So a path that goes to good. So there exists a path that goes to good. So as you can see, I've done this already. Good. Oh, see, I put always here. It's eventually good. Yes. See, if I did G, it exists a path where it's always good. And there's no path to that. It exists a path where eventually it is good. And there it is. Let me zoom in a bit. Add bad, good. So there is our formula. We can just add that in. And you can just click on it here and it will bring up exactly what you want. Yeah. So that was question 1, part 1. Part 2. Now, we have bad, good, bad, good, bad, and bad and bad. So, for our paths, there exists a path where you always get to good. Or, for all paths, there exists good. So for all paths, you eventually get good. So there's a good on this path, you get it here initially, and you get a good on this path and this path. So, let's see, can we do this? For all paths, eventually good. Aha, You see? Add that in. So for all paths, eventually you get good. No matter what path you take, you're eventually going to get the good. The good atomic proposition is going to be satisfied. We went to number 3. So number 3. Okay, so we're looking at our green path, remember? So we have good, good, good. So it's not going to be all paths, as you can see over here. So there exists a path where it's always good. It's good, 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 always on this path. So there exists a path where always good. And there it is. So it's never, you'll never have bad on this path. It's good, good, good. And you see here, this is bad, so that is a counter example. And I forgot, let's save that. And we'll check, and we'll add it into our formula table. So you can click on it now here, you can see the value. Our next question, number 4. Well, now you can see good, 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 good. So for all paths, it's always good. So that's an easy one. So it's just for all paths, always good. So it's going to be good everywhere, basically. So this is the same as in LTL. We just do G of good. But this is a CTL checker, not an LTL checker, so you'll see you won't be able to bring this to positive normal form. So you got to put in our quantifier. All paths, always good. Question 5. Now, here our goods are red and our bad are green. So what do we want for this example? So good, good, and good are all red and our bads are green. So, if you remember, what could possibly make all the goods red? You're looking for good. Well, the strong until looks like this could be the answer. Remember, strong until says the first property must hold until it meets the second property, and the second property must always be found. So if you did all paths strong until good bad, you will get this answer. Why? Because it's saying good must hold. Yes, good does hold. However, it's a strong until bad. So bad must be found on this path. So for all paths where good holds, which is here, bad must eventually be found. So this needs to be bad. However, bad, the second property is never found. Therefore, you get a counter example. So this shows. This is the answer for question 5. I'm going to save these. And now we'll move on to question 6. Now, question 6, you notice it's the exact same model. We have good, 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 and bad, 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 bad. But now the goods are all green. So, instead of doing a strong until, we do the weak until. Good, bad. But this says the second property, bad, does not have to be found if good is always true. And you see, yes. So good, good, good. You see, you saw here. Now you notice when here it was good, it goes to bad, so it held it for the strong until. And example 5, when it was good, it went to bad here. Good, good, it went to bad here. But good, 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 it did not find the second operator. Bad. For the week until, it goes good, good, bad, fine, good, bad, same again. But good, good, good is fine because for the week until, the second property bad does not have to occur as long as good remains true. So that is the answer for part 6. Again, I will leave you to resolve whether you, for question 3, can LTL formula always also satisfy these properties? So you can just go through these, look at the CTL formula and see can you achieve the same with LTL.